Hi guys, welcome back. In this video we're going to take a look at substitution reactions between alkanes and halogens. You may recall that alkanes are saturated hydrocarbons. That means they're molecules built only of hydrogen and carbon, and they only have single bonds. The halogens are the second to last column of the periodic table on the right-hand side. They include fluorine, chlorine, bromine, iodine, and technically astatine, but we usually ignore astatine just because there isn't much of it. Here's how substitution reactions work. As the name suggests, you're going to substitute one atom for another. The substitution happens here. You're always going to have some sort of an alkane. In this case, we have methane. And then you're going to have some sort of a halogen. In this case, we're using chlorine as an example. What happens is one of these atoms of chlorine replaces an atom of hydrogen. Chlorine and hydrogen simply switch. So the chlorine substitutes the hydrogen. When the reaction finishes, we still have 3 hydrogens. In this case, there were 4 hydrogens. Now we only have 3 because one of the hydrogens has been substituted or replaced with a chlorine. Now the substituted hydrogen has to go someplace. It can't just disappear. And where it goes is to a bond to the other chlorine. Couple of comments on this. First of all, substitution reactions are nice because they're already balanced. If you look at them, you'll notice that we have 2 chlorines on the left side of the arrow, 2 chlorines on the right side of the arrow, 1 carbon left of the arrow, 1 carbon right of the arrow, 4 hydrogens left of the arrow, 1, 2, 3, 4 hydrogens to the right of the arrow. So you never have to balance substitution reactions. They're pretty easy to identify because you'll always have hydrochloric acid. Now technically it could be hydrofluoric acid or hydrobromic acid or hydroiodic acid, but we're going to kind of stick to chlorine simply because it's, in my opinion, the most common. And so hydrochloric acid is always going to be a product if you're trying to identify a substitution reaction, and that works pretty well because that's a fairly unique product. There aren't a lot of other reactions that generate hydrochloric acid, at least not that we look at. You say, well, okay, so I substituted a chlorine for one of the hydrogens. Can I continue to substitute chlorine for hydrogen? The answer is yes, you can. You could do this a second time. This molecule of carbon, 3 hydrogens, and 1 chlorine now becomes our reactant. We bring in a brand new molecule of chlorine, and we substitute a chlorine atom for a second hydrogen. Now as a product, we have carbon, 2 hydrogens, and 2 chlorines. The hydrogen that was substituted bonds to the available chlorine, and we have another atom of another molecule of hydrochloric acid. You say, well, if once is good and twice is better, can I do it 3 times? And the answer is, of course you can. We start with this. We substitute a chlorine for a hydrogen. Now we are down to 1 hydrogen, 1, 2, 3 chlorines, and yet another. This is our 3rd molecule of hydrochloric acid. There is still 1 hydrogen available, and so we can do this reaction a 4th time. We need a 4th chlorine molecule. One of the chlorine atoms substitutes for that hydrogen. We're left with this, carbon tetrachloride. That actually gets used in the dry cleaning industry. It's not nice. I believe it's a carcinogen. It's one of the reasons that you don't dry clean yourself in your own house. Pardon me, you don't dry clean your clothes by yourself in your own house. You certainly shouldn't try to dry clean yourself. And then we have our 4th and final molecule of hydrochloric acid. You can do this with any alkane. We've used methane as an example, but you could do it just as easily with ethane or propane or butane. The only difference is that since ethane and propane and butane all have many more hydrogens, you could go through this reaction many more times before you finally ended up with nothing but carbon and chlorine. So these are examples of substitution reactions. You should be able to identify them. You should be able to write them down. One final comment, you'll notice that they're always balanced, which is pretty slick.